Good morning, students. Today, our topic is on cellular architecture. Basically, this is a continuation of the previous lecture, which is Introduction to Cellular Communication System Part 1, and that is why we have chosen to name it as Part 2. Now, starting with the cellular approach, as we can see that we are quite familiar with this particular figure where we can see each cell is having a base station or tower, and obviously this cell region also provides some kind of mobile station, and this base station is connected with this mobile station as well as the mobile switching center, which is further is connected with PSTM. And obviously, this particular base station, as you can see, that this provides a kind of radio access or radio link between mobile users or mobile station and the mobile switching center. So this particular concept utilizes this frequency reuse technique. So to start with frequency reuse technique, we first want to know what are the major counterparts of basic cellular system. These are mobile station, cell site or base station, you can see, mobile telephone switching office, which is MTSO, or mobile switching center, which is MSC, and obviously the data links, the fixed data links. So basically, in modern cellular telephony, rural and urban regions are divided into areas according to specific provisioning guidelines. Now, deployment parameters such as amount of cell splitting and cell sizes are determined by engineers or professionals experienced in cellular system architecture. So, if we closely look at this architecture, we can see that these are the three major units, and this the fourth unit, which everyone is present in this particular figure, where you can see that each cell is having this base station, and obviously there is a province of mobile station. Each base station is connected to the mobile switching center via this fixed data links, and automatically this mobile switching center is further connected to other MSCs and PSTN. So mobile station is a particular unit that contains a transceiver, control unit and antenna. Base station is also a particular unit which has a tower antenna, which is the omnidirectional antenna, transceiver for mobile station, and fixed link obviously to mobile switching center or MTSO. Now, what is mobile switching center? This is a particular building block which is the most important building block, and that is why it is a very complex one. Why? Because this particular building block is the central coordinating system for all the cells, and that is why it contains cellular switch, lots of components, including control computer, mobile management software, user location mobile management software, and obviously it also needs to track the location of all user. That is why it also provides user location registers, interfaces, and links to base station and PSTN. Now, made up of local networks, this PSTN is the exchange area networks and the long haul networks. Now, how do these radio systems plan? That is, obviously, there are certain parameters which need to be highlighted when we are going to plan this radio system using this cellular approach. Those are cell size design, cell location, the identification or assignment, allocation of channels, performance criteria, handoff mechanism, propagation modeling. Now, starting with all those parameters, I just wanted to, go back to the previous slide, which just we have talked about, that is the cellular system architecture, and where you can see this MTSO, as we are all aware now, this is the central administrator and manager. So cellular switch, all the switch which is provided by this MSC or MTSO. All those cellular switches are analog or digital, and it can switch the calls to connect mobile to mobile or mobile to fixed. And coverage area is partitioned into nearly, you can see, hexagonal shaped area called radio cells, where each cell is served by one base station for radio coverage to all mobile units. And all those fixed data links what we are talking about, these radio links carries the voice and signaling information. Obviously these are the channels, we can say, between the mobile station and base station in that cell only, this particular, I mean, within the cell. And base stations are connected to MSC through these fixed circuit cables, or these fixed circuit cables are like microwave cable, or optical fiber cable. So MSC interacts with a database of subscriber data and location information. That is why it contains the user location register, uh, and so on, to provide dynamic terminal location to the switching computer. Now, this MSC is connected to PSTN, as we have just talked about, because majority of calls originate from or terminate at fixed PSTN phones. So every cellular system has some number of radio channels for its use depending on the cellular standard and obviously the RF band. The available radio channels are partitioned into groups of channels, each group being allocated to an individual cell. So these individual group of channels can be reused in distant cells without causing any kind of interference. So now, depending on these total, I mean, the phenomena, now we are going to move towards the certain parameters which help to basically fulfill those particular, process. Now coming to the cells, uh, we know that this term cellular comes from the honeycomb shape of the areas into which a coverage region is divided. So basically the cell is a basic geographic unit, a very small geographic unit of a cellular system, and it is basically the base station which transmits over small transmits a radio access over small geographic areas that are represented as hexagon, as we are just saying. So size of this particular cell varies depending on the landscape. That means what are the area which we are going to cover. So cluster is a group of cells, and number of no channels are reused within a cluster, and that is why you can see that if I say that this is a one cluster, so each cell is having a different kinds of numbering. So we can see that this is a particular cluster where the cluster size, the cluster size is expressed as n. So cluster size is the number of cells present in that particular cluster, and that is why cluster size is 7 here. Fine. Now you can see that this is a particular slide which depicts you the concept of frequency reuse. So if you can see that these here you can have three clusters. You can have three clusters, and you can see that only a number of radio channel frequencies were available for mobile systems. So therefore, engineers had to find a way to reuse radio channels to carry more than one conversation at a time. So what could be the solution? The solution the industry adopted was called frequency reuse. So it is implemented by restructuring, the mobile telephoning system architecture to the cellular concept, as we are just covering. So basically, in this particular, concept, the concept of frequency reuse is based on assigning to each cell a group of radio channels used within a small geographic area. So basically, cells are assigned a group of channels that is completely different from neighboring cells. So basically, what happens that if I number this cell as cell 1, so automatically the neighboring cells cannot be the cell 1. It has to be cell 2, 3, 4, 5, 6, 7 up to n. So now if I now utilize this particular, clusters, by repeating so that we can cover the whole large area, it is called the frequency reuse. Why? Because all the cells with the same number have the same set of frequencies, so we can reuse the same frequency. Like if I go to repeat the same structure. Sorry, this is the slide. If I what I have just what I am just saying, that we can reuse the frequency if we can repeat the particular structure or particular cluster in the large geographic area, so that we can cover the whole coverage region. So if this particular process is being utilized, then the coverage area of cells is called the footprint, and it is limited by a boundary, so that the same group of channels can be used in cells that are far enough apart. And that is why you can see that here cell 3 is quite far apart from the different cell 3, as well as this is the same thing is applied between these two cell 3 cells also. So in that case, this frequency reuse factor is 1 by n. Here n is the number of cells within a cluster. Here that is 7. Now this is a particular slide which depicts you the cell splitting method. Cell splitting means economic considerations made the concept of creating full systems with many small areas becoming impractical. So to overcome this difficulty, cell splitting was developed. So as a service area becomes full of users, this approach is used to split a single area into smaller ones. So basically this cell splitting this technique allows the urban centers to be split into as many areas, whereas the large, less expensive cells can be used to cover remote rural areas. So you can see that whenever where we are having the rural areas, we can create larger cells because we have less expensive. Low use of data, or low use of less traffic. You can say, and obviously in the urban areas we are creating very small cells so that we can create large number of clusters, so as to avoid the traffic congestion in very high traffic regions. Now the typical last obstacle, you can say in the development of the cellular network, that involved the problem created when a mobile subscriber moved from one cell to another, and obviously whenever he or she is during a call, so adjacent areas do not use the same radio channels. It is obvious, quite obvious. So a call must either be dropped or transferred from one radio channel to another when a user crosses the line between adjacent cells, because this is a kind of hexagon cells. This is the one, another hexagon cell. This is another hexagon cell. So whenever this user crosses between these adjacent cells, since dropping the call is unacceptable, therefore handoff was developed. Handoff occurs when the mobile telephone network automatically transfers a call from radio channel to another radio channel as mobile crosses the adjacent cells. You can see that this is the edge of the two cells. So this is the point where this particular user is going to face the handoff. So the system switches the call to a stronger frequency channel in a new site without interrupting the call or alerting the user. So during a call, two parties are on one voice channel. So this is a very beautiful technique which helps to you know which helps user not to get any kind of interference, not any kind of call drop during a particular important call. So this is the today's lecture, and we have already come to the end of this particular lecture. If you have any queries, you can do ask me regarding the particular link I will have to upload on Google Classroom, and you will have to solve one Google form having